Question 11.52. Two polarizers are out of alignment by 30 degree. If light of intensity 1 watt per meter squared and initially polarized halfway between the polarizing angles of the two filters passes through the two filter, what is the intensity of transmitted light? So here in this question we have two polarizers which are out of alignment from each other by 30 degree. So if I have polarizer 1 and polarizer 2, polarizer 2 is making an angle of 30 degree with respect to polarizer 1, whereas light of intensity I naught is initially polarized halfway between them. That means polarizer 1 is making an angle of 15 degree, which is half of 30 with the vertical. We need to find what is the intensity of the transmitted light. So we are going to use Malu's law to calculate intensity of light coming out of polarizer 1 and 2. So first through polarizer 1, we can write the light of intensity coming out of it to be I1, which will be equal to I naught cosine squared theta 1. Theta 1 is 15 degrees, so I can write this as I naught cosine squared 15. Then we find the light intensity coming out of polarizer 2. I2 will be I1 cosine squared theta 2. I1 is the light coming out of polarizer 1, which is then incident on polarizer 2. Theta 2 here is 30 degree because 1 and 2 are out of alignment by 30. 1 is making an angle of 15 degree initially with I naught, but not with polarizer 2. Between polarizer 1 and 2, the angle is 30. So we get this as I1, which is I naught cosine square 15 into cosine square theta 2 is 30. So I naught is 1 watt per meter squared. So 1 times cosine squared 15 into cosine squared 30. That gives me I2 to be equal to 0.699 watt per meter squared, or you can round this off to 0.70 watt per meter squared. So this is the intensity of the transmitted light. Question 11.54. Unpolarized light of intensity I naught is incident on a series of 5 polarizers, each rotated 10 degree from the preceding one. What fraction of incident light will pass through the series? So here we have an unpolarized light of intensity I naught, and it is passed through 5 polarizer, each rotated by an angle of 10 degree from the preceding one. So let us assume the first polarizer to have vertical pass axis. That means it will only allow vertical vibrations to pass through and block all of the horizontal vibration. The second polarizer will be rotated by 10 degree from the first. So we call that angle as theta, which is 10. Third polarizer is increased by another 10 degrees, so it's making an angle of 20 degree with the vertical. Fourth will make an angle of 30, and fifth will make an angle of 40 degree with respect to the vertical. We need to find the intensity of light coming out of the fifth Polaroid. So we start with polarizer 1. Since polarizer 1 is vertically aligned, it only allows vertical vibrations and block all of the horizontal ones. So intensity of light coming out of polarizer 1, which is I1, will be half of the original intensity. Then we find intensity coming out of polarizer 2. I1 is incident at 2. So we find I2 using Malu's law, which will be I1 cosine square theta. So we can find this as I naught by 2 cosine squared 10 degree. Then this is incident on polarizer 3. We can find intensity coming out of polarizer 3 as I3 equals I2 cosine square theta 3. Theta 3 is the angle between polarizer 2 and polarizer 3. And you can find this by subtracting the angles they make with the vertical. So it will be 20 minus 10, which is again 10 degree. So we get this as, substitute for I2, I naught by 2 cosine squared 10 into cosine squared theta 3, which is also 10. That gives you I3 to be equal to I naught by 2 cosine to the power 4, 10. Then we find I4. I4 will be I3 cosine squared theta 4, which you again get as 30 minus 20, which is 10. And theta 5 will also be 40 minus 30, which is 10. So when we are finding this, we are just basically multiplying cosine square theta over and over again to calculate the final intensity. So I4 will be I3, which is I naught by 2 cosine to the power 4, 10 into cosine square 10. And I5 will be I4 cosine square theta 5, which is I naught by 2 cosine to the power 6, 10 into cosine square 10. That gives you I naught by 2 cosine to the power 8, 10. So let's calculate this. This becomes equal to 0.44 times I naught. So the intensity of light after passing through the series becomes 0.44 times the original intensity. Anytime you have a question like this where they give you a series of Polaroid, where each preceding Polaroid has the same angle from one another, you can find the final intensity to be equal to initial intensity by 2 cosine to the power of 2 n minus 1 theta. So here n is 5 because there are 5 polarizer. N minus 1 is 4. 2 times 4 will be 8. So you can remember this as a general rule if there are series of polarizer and calculate the final intensity using this rule.